So today what we're going to do is review properties of exponents. So you have this small booklet, and I'm going to ask that you kind of pause and you start going through these on your own and seeing what you remember from previous years. So the first one, products, exponents, and the product rule. What is the difference between these? Well, you could say in words you might use, or you might use mathematical expressions. So 3x versus, let's make this a little smaller, x times x times x, because that to the power of 3 means you write it out 3 times. So when we take a look at these, repeated multiplication, 2 squared, we have 2 of them, and then 3. So 3 to the 4th would be 1, 2, 3, 4. And then we have 3 to the 5th, so times 1, 2, 3, 4, 5. So how many is that? That's really 3 to the 9th. So we could continue writing these out. Let's try this one. So we have 1, 5, and then we have 4 5s, 2, 3, 4. And then we have 3 5s, 1, 2, 3. Multiply all these together, so 5, 1, 2, 3, 4, 5, 6, 7 to the 8th power. So some of you might notice we're adding these, so x to the 16th. So determine a general rule. So if the same base, you add the exponents. And well, why do you think it's called the product rule here? Well, we're definitely multiplying. So an algebraic rule, if we have x to the m times x to the n, that equals x to the m plus n. So let's see if we can get to the next one in your book. It's the distributive rule for products. So again, if you go through and write these down, let's see, so this would be 3 to the 5th, 1, 2, 3 to the 6th power. So we have 3 to the 6th, that's kind of a 3 to the 6th over 5 to the 6th. So as you guys can see, we're just distributing these down. So this one here, our 2x, whoops, we would have 2 to the 3rd, x to the 3rd over 9 to the 3rd. So this one is all to the 10th, so this has to be 3a divided by 12b to the 10th power. So another way to write it would be a to the n divided by b to the n. So a general rule, we could use just what we had up here. A over b to the n power, a to the n over b to the n. So why is it distributing? Because we're actually distributing there. So the next one, it looks like you have the quotient rule. So our quotient rule, well, let's see what happens here. So we have 7 3s, 1, 2, 3, 4, 5, 6, 7, divided by 1, 2, 3, 4. So we have 3 to the 3rd left. So if they're too big, let's see what's happening. We had 3 and 2 and 1, 7 and 4 made 3. It looks like we're subtracting. So this would be 5 to the 5th, y to the 12th. And so there's quite a few ways that you could get this one. We could have started with, let's see, a to the 10th over a to the 3rd. Let's see, and then we ended up with a b to the 3rd. So maybe this was b to the 7th, b to the 4th. There's tons of possibilities there. So in general, if we have a to the m over a to the n, we subtract there. So So the rule for zeros, let's see. So if we use the quotient rule, this would be 2 to the 3 minus 3, or 2 to the 0. Well, this would be 5 to the 7 minus 7, 5 to the 0, x to the 20 minus 20, x to the 0. So look at the original quotient. If that was just a number, it's the same thing. So we'd say those are all 1, so it's equal to 1. So the next one here, let's see, the distributive rule for quotients. Oh, we did that one. Whoops. So the second distributive rule for products. Let's see. So we have it 4 times. So 4 to the 6th, 4 to the 6th, 4 to the 6th. That got a little messy. Let's try. Make this a little larger here. 4 times 6, 4 times 6, 4 times 6, 4 times 6. Well, I see that we have 4 4s and 6 4s, so this has got to be 4 to the 4th, 6 to the 4th. So if we're distributing, this would be 3 to the 6th, x to the 6th. So again, as a rule, if we have, oops, a times b to the n, this is a to the n, b to the n. So what ones haven't we done yet? The power rule. All right, 2 squared to the third, so we write it out 3 times. So that's 2 to the 6th. So 5 to the third, 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 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5. So that is 5 to the 12th. So what are we doing? It looks like we're multiplying there. So this one would be a to the 20th times 32. So if we had a to the m to the n, a to the m times n. Product rule. How is this different than the product rule? Well, if we look at this one over here, there's parentheses here. So this power rule is when we have 2 powers. Let's see, is there a last one? I think we have negative exponents. All right, so negative exponents. Let's see. Well, we could think of this as a product rule, so 1 over, this would be a to the 5th, which is the same as, so a to the 4 minus 9, a to the negative 5. So let's see, it looks like a power rule. So a negative exponent, it changes sides of the fraction. So if we had, let's see, algebraic rule, if we had a to the negative n, that's 1 over a to the positive n. So let's have you pull out your homework packet here. And we'll take a look at a couple of those. So you're going to be taking a look at some properties of exponents here. And some of them range from really easy to some that'll be a bit more challenging. For example, this first one. We know this is that power rule, so we're going to multiply these. So x to the negative 12 times 2x to the 4th. Well, we know we add, so that's 2x to the negative 8. We can't have negative exponents, so 2x to the power of 8. And we could take a look at maybe number 10 as well. Let's see. We have to distribute there, so 10m to the negative 4th divided by 2 to the negative 3rd. That would be m to the positive 12. So let's see, we got 10, that m to the negative 4th, so that would change to the denominator. 2 to the 3rd on top, times m to the 12th. Well, 2 times 2 times 2 is 8. So we have 80 over m to the 16th.